The frame counter on a Retina 1A or 2A camera. As you are probably aware, that spring, that counter spring in here is prone to failure. See if I've got an example here I can show you. It should look like this, with an end on it. More commonly, they look like that, with the little end snapped clean off. And that happens just through wear and tear basically. It's just not a wonderful design. In action, every time the frame counter moves one notch, this little tab pushes the wheel forward one notch. As the advance lever returns to the rest position, this little thing shifts backwards. This has to hop over the ratchet ball, the little ratchet teeth, which means that basically it has to flex at this point. Now, after thousands and thousands of flexings, they break. You can also kill them instantly. You can be sudden death if you decide you really don't like your frame counter and you want to kill it for good. Just turn this dial the wrong way. It's got a little arrow on it saying which way to turn it. You just force it the other way, you'll break this instantly. And so a lot of them are broken just like that because somebody didn't look, didn't take care, and just forced this around in a anti-clockwise direction and broke the thing off. So these things, getting hold of a good one of these used to be a matter of hunting around the place. I had a good supply of them. I think I had 40 or 50 of them at one stage that I bought from the estate of another repairer. And I gathered up a few strays along the way too. As I saw them arise, come up on the likes of eBay, I'd buy them. And all good things come to an end. And one day, I had used up all of my stock. You used to be able to get what was purported to be a reproduction part on micro tools. And whether it was a reproduction part or whether it was a repaired part, I just don't know. But they used to be available, and they used to be quite a bit of money. I think they were either $50 US or certainly give or take a few cents in that region, which is a hell of a lot of money, of course, for a little piece like this. Now that they're not available at all, or don't seem to be, they're a bother. So what can you do to fix it? Well, various people at various times have soldered a piece of spring steel on the end of these and shaped it accordingly, and that's worked. Depending on how brittle or flexible the spring pieces that they used, it would work for a short time or a long time. There's no reason to believe that they worked on average any worse than the original part. But it's very cumbersome to do. You're trying to solder to a tiny little tab here, and you're trying to solder something to it that probably doesn't really want to solder particularly well. It's spring steel. You'd probably have to use some sort of flux to do that. If you start splashing around liquid fluxes, it's going to get in and around and under things, and you are going to have to wash that down very carefully to get rid of that flux, or things would just rust away in no time flat. I know because I've done silly things like that myself in the past, not with these but with other things. So I've been looking for a solution to that problem. Now, because I was doing repairs frequently, I needed a method which was quick and reliable and tidy and would just produce a good result each time. So I worked away. I was thinking about that for a long time, about how I might achieve that, and eventually I came up with a potential solution. The first thing I did was I took a pair of vernier calipers and I measured the thickness of that spring. I took a known good part and measured this distance here, the width of that tab. And that told me how thick the metal needed to be and how wide I needed it to be. And then I pondered, where am I going to get spring steel that will do that job and doesn't come in 8-foot by 4-foot sheets or some other ridiculous amount like that, and that I'll be able to cut to size. And eventually I struck on an answer. Now some of you may recognise this. It's the mainspring from a watch. And mainsprings for watches have been made in all sorts of thicknesses and widths and lengths for that matter for many years, and there's a huge variety available from watch part suppliers. So I ordered a couple of likely looking watch springs and started with the first one, which turned out to work very well for me. But that doesn't explain how I was going to join things together. One day when I was idly looking on AliExpress, I think it was, for tools that I probably didn't need that I should buy because they were so cheap, I saw these little spot welders, supposedly a 5,000 watt spot welder, and they were reasonably cheap. And I thought, well, that's interesting. That could be worth a go. These are designed for spot welding tabs, connecting tabs onto cells to create batteries for your rechargeable tools and so forth. And I thought, well, perhaps that would work for the steel. So I bought one and moved on from there. The way these things work is you have two probes like this. Here are your electrodes. You set the device to give you a pulse of the appropriate time, and you have a foot pedal to trigger the device. The spot welders are actually battery powered. They've got an internal battery you have to charge up. They don't run direct from the plug pack. So you take your two probes, you'd hold that on the strip of metal next to each other where you're wanting to weld things, press the pedal, bang, and the metal gets spot welded where those 2 points are. And I thought, well, I could use that to put these springs together. But how the hell was I going to be able to hold the little frame counter spring? How was I going to locate that? How was I going to hold my two probes? And how was I going to hold the spring all in one place? So I pondered on that for a while because, you know, all sorts of fanciful jig ideas came to me and were dispensed with because they'd require an awful lot of work and machining, and they'd require tiny little clamps. Well, you've seen how small these pieces are. It'd be like a tiny little pin holding something down, and that could never work. So this is what it came down to in the end. I've got a slab of copper. I've got one of my electrodes is screwed into the slab of copper. I would take my dead frame counter spring. I have a slot milled in here so there's room for it to sit. I have a groove cut into the side to locate that pin. So this sits in here like that, and it can't go anywhere. It's trapped neatly. I don't need to muck around with it. I don't have a problem holding it. And all I've got to achieve is to lay my spring on the top. Like that. I can line that up by eye. It's not complicated. It's not particularly difficult. I just take the probe here, set it on the top, press the foot pedal, and that gives it a quick zap. That's spot weld number 1. Now I don't know if you've had anything to do with spot welds, but having one spot weld holding something is no good because you've only got to twist things slightly and it'll just tear them apart. So you needed 2 spots welded on there. So I'll show you how I do that. See if I can get this in position where I can use it and you can see it. Turn that to about there would be about right for me, I think. Gotta get the foot pedal where I can find it. Lay my spring on there, making sure it's parallel with the jig. Take the probe, hold it on there, hit the pedal. One spot weld. Go along a little bit. Two spot welds. And there I have my frame counter spring spot welded to my spring. Turn this off. Okay, so what do I want next? Well, next I want to bend the end of that spring over. So I'm holding this with a pair of pliers right up to the end of that joint and just bend the spring down. I'm just bending it against my thumb. Until I've got something that looks like that. And then I cut it off with a pair of cutters, knowing that I want something that looks like that. So it's not overly difficult. Just line that up. When I'm happy it looks right. And basically there's my frame counter spring. Now you can improve them slightly if you like. Just making sure that the end is not rough. And then I normally fit them into the camera and check for their behaviour, see if they work well. So I will just take the film advance off this Retina IIa here and we'll fit this thing in place. Right, well, I'll take out the existing one and put the new one in position. Well, it certainly makes ratchet noises in a suitable fashion. I'll pop that back on the camera. It seems okay. And there we have it, the frame counter's working. So that was how I put a new tip back on a broken frame counter spring from a Retina IIa. And you know, I recognise that if you had one to do, shelling out what amounted to about 200 New Zealand dollars in order to get all the pieces together might be a bit much. But if you had 4 or 5 to do, the gear would pay for itself straight away. Thanks for watching.